Okay, welcome to session 8 of the AQA Further Maths course. Now, this session we're in chapter 3. We're going to do functions, start functions, and do some range and domain, which might be new to a lot of you, but you'll be fine. Right, let's get cracking straight in. So, I'm going to start with some basic function notation, which you will have seen before. So let's go straight in with an example. So let's say fx equals 10 minus 4x and gx equals x cubed. 1, find f minus 1. Okay, so to find f minus 1, you literally just replace x with minus 1 in the fx function. So f minus 1 will equal 10 minus 4 times minus 1. So f minus 1 is going to equal 10. That's going to end up being 14. That's my answer. Okay. So part 2. Write down an expression for f 3x this time. Okay, so even though this time you do exactly the same, but you replace x with 3x. So f 3x, it applies to the same function as the start of the question. 10 minus 4 3x. Okay, f3x is going to be 10 minus 12x. It doesn't simplify any further, so that's my answer. And finally, solve gx equals negative 64. Okay, so I go to my gx function. Gx is x cubed, so x cubed equals negative 64. If I cube root both sides, I get x is equal to minus 4. Okay, right, pause the video at this point. I want you to do exercise 3a this time, which is on page 43. I think it might go over to 44 as well. And I just want you to do the evens. So just the even questions, please, on that exercise. And when you're ready, when you've done those and marked them, come back and we're going to move on to range, domain, and sketching. Okay? Range, domain, and sketching when you're ready. Right, you need to know that the domain is the values you can input into a function. Okay, this is usually the x values. Not always, but it's usually the x values. And the range is the values that can be output. So what values can come out of that function? And again, this is usually the y or the fx values. It might be gx. Okay, so they're the two definitions. And it's much easier to sort of see what's going on with an example. So e.g. fx equals 6 minus 4x. Now sometimes you will start to see things like this now with functions. They might put a bit on the end there. This is the domain. Okay, they have said what the domain is. Now the question means write down the domain. So if you see some sort of inequality on the right side there after a function like this, it is telling you that that is the domain of the function. Those are the only allowable inputs. So you're only allowed to input values from minus 2 to 3. So question 1 might be write down the domain. So what values are you allowed to input? Well, the question has restricted me. The answer is any value between minus 2 and 3. Okay? There's a bit of a trick question. Now the second question, it might be sketch fx, and this is where the previous session's really going to help you. So we're going to draw the graph fx equals 6 minus 4x. Now, you should spot that this is a linear. It's a linear graph because it's just got x and an fx in. And you would normally work out the x-intercept and the y-intercept. But for this case, I've got the domain, the smallest it can be. I don't draw the graph anywhere other than between x's minus 2 and 3. Beyond that point, the graph just stops, okay? So when it's useful to just use the extremities here. So when x is minus 2, what is fx is a little bit like y, so I'll just put fx there. So when x is minus 2, fx is going to equal 6 minus 4. It's going to be 6 at 14. So I'm going to put, so the graph starts at 14, and when x is on the far side of the domain, when x equals 3 this time, fx is going to equal 6 minus, that ends up being 12. So it equals minus 6. So it comes down to minus 6 there. And I just draw a line between the two. Okay. Be a little bit careful. I get the, yeah. I could, if I wanted to, work out that. That's when y is 0. I think you should end up with about 6 over 4 there. So I need to make sure that's the right side of the origin. And that is my graph. I deliberately stop between minus 2 and 3. Okay. Now, 3, write down the range. Write down the range of fx. Okay, what are the possible values of fx? So, what are the possible outputs of fx? Well, the highest it could be is there. The top of that graph, so 14 is the most it could ever be. It's less than or equal to because the domain was less than or equal to. The smallest this graph, this function can take is the lowest value on there, which is minus 6. So it's going to be bigger than or equal to minus 6. So that would be the range of this function. Okay. Right, again, just pause the video at this point. I want you to have a go at page 45, questions 1 to 8. I want you to do the first and last part, please, of each question. Okay, and we've got one more bit. We're going to be sketching multiple domains. So when you've done those questions, graphs with multiple domains, new title, and straighten again with an equal. So draw the graph fx equals 4 minus 4 x minus 2 x squared. Now we're looking at these sort of things, look like serious maths now. But once you just take your time and understand what's going on, you'll be absolutely fine. And you might even see something, it might look like that. Okay. So draw the graph. What this means is this graph is fx equals 4 between minus 4 and minus 2. Okay, so between those two values of x, the graph is just fx equals 4. Or if you want to think about it, it's basically y equals 4. So I can draw straight in there fx, same as y, between minus 4 and minus 2, minus 4 and minus 2. Remember, fx equals 4, that's just a straight line that passes at 4. Okay, so I just draw that bit of the graph and I stop between those two. Next bit, so fx equals x squared between minus 2 and 2 this time. So 2, I can do 2 there. Now, the x squared graph looks like it's a U-shaped parabola. Okay, so x squared on the extreme, so if I square minus 2 I get 4, and x squared is going to be like a U-shaped parabola up to 2, and it stops there because 2 squared is 4, 0 squared is 0, and so on. And that's good enough for this sketch. And the final part, fx equals 8 minus 2x between 4 and 2 this time, so 4. Okay, it's a linear graph again. So I check when x equals 2, fx is going to, if I put 2 in there, I think I get 4 as an output. So that's exactly the same as the previous part, so that's okay. And finally, when x equals 4, fx equals, if I put 4 in there, I get 8 minus 8, so I get 0. So at 4, and remember this one is a straight line, so I join the point from the first to the last point, and that there is my finished graph. Okay, that's my finished graph. Finally, it might ask what the range is for this function. So what is the range for this function? Question 3. Well, what's the biggest it can be? The biggest it can be, there's nowhere on the graph that takes it bigger than 4. So 4 is definitely going to be the biggest. And the smallest it can be on the y-axis is 0. So fx here is going to be less than, remember it was less than 4 this time, so it's going to be, so it can be equal to 2, so it's going to be less than or equal to 4, and it's going to be greater than or equal to 0, again because 0 could be there, it's less than or greater than or equal to. And that would be the range of that function. Okay, a little bit new, that stuff. It does take you a little bit of time to get your head around that. But when you do page 73, 74, that exercise there, and I want you to do the odd questions, please. The whole of each odd question. Okay, and that's a big chunk of functions done. Good luck, and tune in for the next session next week.